March 17th, 1943. Tunis Artillery Range, North Africa. Hauptmann Friedrich Hartmann approaches a gun that will shatter everything he knows about artillery doctrine. Not a German 88, not a captured Soviet piece. An American 105mm Howitzer, pulled from the mud at Kasserine Pass 3 weeks earlier. Hartmann has commanded artillery batteries for 6 years. He knows what to expect from field guns. The mathematics are absolute. Weight determines mobility. Complexity ensures precision. Time requirements are fixed by physics itself. This American piece sits oddly light on its carriage. The trails look almost delicate. The breech mechanism appears simplified to the point of crudeness. Nothing about it suggests the performance characteristics German intelligence has reported. 8 rounds per minute sustained fire. The number is impossible. German crews achieve 4 rounds per minute with the FH-18, and only after years of drill. 8 rounds per minute would require eliminating half the loading sequence, compromising precision, or inventing new physics. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Hartmann circles the howitzer slowly. His trained eye catalogues every detail. The split trail design, the horizontal sliding breech, the simple elevation mechanism. Everything speaks of American preference for straightforward engineering over German sophistication. But then he reads the data plate. Weight in action, 4,460 pounds. His breath catches. The German FH-18 weighs twice that, 7,716 pounds without the limber. This American gun achieves comparable range and firepower at half the weight. He orders the piece prepared for firing trials. If the intelligence reports are accurate, if 8 rounds per minute is actually possible, then German artillery doctrine has been built on false assumptions for 2 decades, and the Americans have known it all along. The morning sun had barely cleared the horizon when Hauptmann Friedrich Hartmann arrived at the Wehrmacht artillery testing facility outside Tunis. The air still carried the coolness of the North African night, though by noon the proving grounds would bake under temperatures approaching 40 degrees Celsius. Hartmann had made this journey countless times since assuming command of the evaluation section in 1941, but today felt different. Today, German certainty would collide with American reality. The captured M101 105mm Howitzer sat under canvas shelter near the firing line, its olive drab paint faded and chipped from combat service. Tunisian dust clung to every surface despite the crew's attempts at cleaning. The gun had been recovered from an abandoned American position at Kasserine Pass, along with 24 rounds of high-explosive ammunition and a single technical manual that some American artillery officer had failed to destroy during the hasty retreat. Hartmann had spent the previous evening studying that manual. The document revealed more through what it omitted than what it contained. No lengthy discussions of ballistic theory. No complex mathematical tables requiring university education to interpret. No detailed maintenance procedures demanding specialized training. Just simple, direct instructions that assumed the crew possessed basic competence and nothing more. The American philosophy appeared to be that artillery should be operated by soldiers, not mathematicians. He approached the howitzer with the systematic methodology that 6 years of artillery command had ingrained. Observe the whole first, then examine the components, then synthesize understanding from accumulated details. The gun's profile looked wrong to eyes trained on German equipment. Too light. Too simple. The trail legs splayed at angles that seemed insufficient for recoil absorption. The shield protecting the crew appeared almost decorative rather than structural. Oberleutnant Klaus Weber stood beside the piece, notepad ready. Weber had transferred to the evaluation section after being wounded at Tobruk, a fragment of British shrapnel through his left shoulder, leaving him unfit for frontline command but perfectly capable of technical analysis. His engineering background from Stuttgart Polytechnic made him invaluable for assessment work that required understanding both military doctrine and mechanical principles. First impressions? Hartmann asked, though he suspected he knew what Weber would say. It looks American, Weber replied, which captured everything in 2 words. American equipment always looked unfinished to German eyes. adequate rather than excellent, functional rather than refined, as if the designers had stopped working the moment they achieved minimum acceptable performance instead of pursuing theoretical perfection. Hartmann knelt beside the left trail leg and ran his hand along the tubular steel construction. The Ley FH-18 used box section trails, heavier and more rigid, requiring mechanical complexity to fold for transport. These American trails were simple tubes with minimal reinforcement, relying on geometry rather than mass for strength. The weight savings were immediately apparent. 2 men could maneuver this trail into position. German trails required 4 soldiers and considerable effort. The breech mechanism drew his attention next. German artillery employed vertical sliding breeches or interrupted screw designs, each requiring precise machining and careful maintenance. This American piece used a horizontal sliding block, so simple it appeared almost primitive. A single lever opened the breech. Another lever extracted the spent casing. The entire operation looked like it could be performed by a soldier with perhaps an hour of past training. He opened the breech and examined the chamber. The bore showed wear consistent with extensive use, but no signs of excessive fouling or erosion that would indicate manufacturing defects or poor metallurgy. American steel quality had proven surprisingly reliable across all captured equipment. Their industrial base might lack German sophistication, but it produced consistent results that held up under combat conditions. "Prepare for firing trials," Hartmann ordered. "I want to verify these performance claims before I file any reports that will make me look insane to the Artillery Directorate." The intelligence summary that had prompted this evaluation sat in Hartmann's field desk, marked with red classification stamps and routing numbers, indicating it had passed through multiple verification levels before reaching Tunisia. The key paragraph had been underlined by someone at OKW headquarters, probably because it contradicted everything German artillery doctrine accepted as physical law. American M101 Howitzer crews observed achieving sustained fire rates of 8 rounds per minute during engagement at Sidi Bouzid. Rate maintained for 17 minutes without mechanical failure or crew exhaustion. Accuracy remained acceptable throughout engagement. German doctrine considers 6 rounds per minute theoretical maximum for field artillery of comparable caliber. 8 rounds per minute. Hartmann had checked the arithmetic 3 times, suspecting either a reporting error or American propaganda. German gun crews trained for years to achieve 4 rounds per minute with the Ley FH-18. Achieving 6 rounds per minute required perfect coordination, flawless ammunition handling, and conditions that rarely existed in actual combat. 8 rounds per minute seemed to violate the fundamental time requirements of artillery loading sequences. Loading a field gun required specific steps that could not be eliminated or shortened beyond certain physical limits. Open breech. Load projectile. Load propellant charge. Close breech. Aim. Fire. Extract spent casing. The sequence demanded 7 to 8 seconds minimum, assuming ammunition was immediately available, and the crew performed each action without hesitation. That established a theoretical maximum of approximately 7.5 rounds per minute, assuming 0 time for aiming adjustments or ammunition selection. But theory assumed conditions that never existed in combat. Crews tired, breeches fouled, ammunition handlers stumbled, aiming required constant adjustment as targets moved or priorities changed. German artillery schools taught that 4 rounds per minute represented excellent sustained performance for experienced crews operating under favorable conditions. 6 rounds per minute was considered sprint pace, maintainable for perhaps 2 or 3 minutes before exhaustion or mechanical issues forced slower rates. 8 rounds per minute sustained for 17 minutes suggested either the Americans had discovered new physics or German doctrine was fundamentally wrong about something important. Weber had assembled a gun crew from the evaluation section's permanent personnel, 5 men, all experienced artillerymen with at least 2 years of combat service. Wachtmeister Hans Dietrich would serve as gun commander, a role he had performed for 3 years with a Ley FH-18 battery before transfer to testing duties. The crew would fire using German procedures first, establishing a baseline, then attempt to replicate American methods using the captured technical manual as a guide. Hartmann watched as Dietrich positioned his crew around the howitzer. Each man knew his role through countless repetitions. Gunner on the left, controlling elevation and traverse. Loader on the right, handling projectiles. Two ammunition handlers positioned behind the piece, preparing rounds and propellant charges. Assistant gunner standing ready to perform any task, requiring additional hands. Load high explosive. Charge 5. Dietrich ordered. Standard procedure. Test the piece with moderate propellant load before attempting full charges or maximum rates of fire. The loader lifted a 33-pound high-explosive projectile from the ready rack and guided it into the chamber. The weight and bulk required both hands and careful technique to avoid fumbling. Projectile seated, he stepped back. The assistant gunner lifted a green cloth bag containing the propellant charge and pushed it into the chamber behind the projectile. The loader closed the breech with a solid mechanical click. "Gun loaded," the loader called. Dietrich checked the aiming stakes, made minor traverse adjustments, then stepped clear of the recoil path. Fire. The gunner pulled the lanyard. The howitzer roared and leaped backward against its trail spades, recoil mechanism absorbing the violence of discharge. The spent casing ejected automatically as the breech opened, clattering onto the ground beside the trail. Smoke drifted across the firing line, carrying the acrid smell of burned propellant. Hartmann checked his stopwatch. Dietrich was already calling for the next round. The crew moved through their loading sequence with practiced efficiency. Projectile loaded. Propellant charge loaded. Breech closed. Aim verified. Fire. The second round departed 14 seconds after the first. They continued firing, establishing a rhythm that represented good German artillery performance. Rounds 3, 4, and 5 followed at similar intervals, 13 to 15 seconds between shots. The crew was sweating despite the morning coolness, the physical demands of handling 33-pound projectiles combining with the stress of being observed during evaluation. After 10 rounds, Hartmann called a halt. He checked his notes. Average time between shots, 14.2 seconds. That translated to 4.2 rounds per minute, exactly what German doctrine predicted. For experienced crews operating a well-maintained piece, the Le FH-18 would have performed identically under the same conditions. "Acceptable performance," he told Dietrich. "Now, I want you to try something that will either prove the Americans are lying or prove we've been doing this wrong for 20 years. He handed Dietrich the captured American technical manual, opened to the section on sustained rapid-fire procedures. "Read this. Then try to replicate their methods." Dietrich scanned the page, his expression shifting from confidence to confusion to disbelief. "Sir, this describes loading procedures that eliminate aiming adjustments between rounds. They're just firing as fast as they can load." "That's what the manual says," Hartmann agreed. "The question is whether it works." The American firing doctrine, as described in the captured manual, violated several principles. German artillery considered sacred. German crews aimed each shot individually, adjusting for wind, target, movement, and barrel wear. American crews apparently aimed once, then fired multiple rounds without adjusting, accepting decreased accuracy in exchange for increased volume. German procedure emphasized conservation of ammunition through precise fire. Each round should hit the target, minimizing waste. American procedure emphasized overwhelming the target area with sufficient volume that precise accuracy became unnecessary. Different questions, different answers, different philosophies. But the most radical difference was in the loading sequence itself. The American manual described a method that kept the breech closed until the previous round had been completely prepared. Instead of opening the breech immediately after firing, American loaders waited until the projectile and propellant charge were both ready, held by crew members positioned for immediate loading. This eliminated wasted seconds when the gun sat ready, but the ammunition was still being prepared. Dietrich positioned his crew according to the American diagram. Loader and assistant gunner stood with the next projectile and propellant charge already in hand, ready for immediate loading, the instant the breech opened. The two ammunition handlers prepared subsequent rounds in advance, creating a buffer that would keep ammunition flowing without delays. "Fire when ready," Hartmann ordered. "Maintain American pace for as long as you can." The first round fired. Before the recoil had fully dissipated, the loader had opened the breech and thrust the waiting projectile into the chamber. The assistant gunner followed immediately with the propellant charge. Breech closed. Fire. The second round departed 7.8 seconds after the first. Hartmann's eyes widened. That was nearly twice as fast as German procedure. The crew continued. Third round at 7.5 seconds. Fourth round at 8.1 seconds. The pace was relentless, demanding perfect coordination and constant motion. Each crew member knew exactly what needed to be ready and when. No wasted movement, no hesitation. The American system was not just faster, it was optimized to eliminate every unnecessary second from the loading cycle. After 20 rounds, Dietrich called a halt. The crew was breathing hard, sweat staining their uniforms despite the cool morning air, but the howitzer was undamaged. The breech mechanism showed no signs of stress. The recoil system had absorbed the punishment without issue. The American piece had performed exactly as advertised. Hartmann checked his stopwatch and performed the calculations. 20 rounds in 2 minutes and 37 seconds. Average time between shots, 7.85 seconds. That translated to 7.6 rounds per minute, sustained over 20 rounds. The Americans had not been lying. 8 rounds per minute was absolutely achievable, and German crews could replicate it using American methods. Weber was writing furiously in his notebook, calculating the tactical implications. "Sir, if American crews can maintain this rate of fire, they achieve double the volume of fire compared to our guns. That means 6 American howitzers deliver the same fire density as 12 of our lay FH-18s. Hartmann understood the mathematics immediately. Fire density determined artillery effectiveness in combat. A battery that could deliver twice as many rounds in the same time period could suppress twice as many targets, deliver twice as much destructive effect, or sustain fire support twice as long with the same ammunition expenditure. The tactical advantage was overwhelming. But there was more. The M101 weighed half what the Lehr FH-18 weighed. That meant it could be towed by lighter vehicles, positioned in softer terrain, and moved more quickly between firing positions. American artillery could shoot faster and relocate faster, making them harder to counter battery while delivering superior fire support. "Continue testing," Hartmann ordered. "I want to know the maximum sustained rate and how long they can maintain it before crew exhaustion or mechanical failure." If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Over the next 4 hours, Dietrich's crew fired 197 rounds through the captured howitzer, exploring the limits of American rapid-fire doctrine. They achieved peaks of 8.4 rounds per minute during several trial sequences. They maintained 7 rounds per minute for stretches of 15 minutes or more. They discovered that the limiting factor was not mechanical but physical, crew endurance rather than equipment capability. The howitzer itself performed flawlessly. The breech mechanism, despite its apparent simplicity, operated without failure through nearly 200 loading cycles. The recoil system absorbed the punishment without leaking hydraulic fluid or showing decreased damping effectiveness. The trails remained stable even in the soft North African soil that would have required trail spades or firing platforms for heavier German pieces. Hartmann examined the breech mechanism after the firing trial concluded. The horizontal sliding block showed wear patterns consistent with extensive use, but no damage or excessive erosion. American metallurgy was proving consistently superior to German expectations. Their industrial base might lack sophistication, but it produced components that held up under conditions that would destroy poorly manufactured equipment. "Pack everything," he told Weber. "I need to compile a comprehensive report, and nobody at OKW will believe these numbers unless they're backed by meticulous documentation." That evening, in his quarters overlooking the Mediterranean, Hartmann began writing the assessment that would force German artillery command to confront uncomfortable truths about American capabilities. The Data told a story that contradicted 2 decades of German doctrine development and suggested that American artillery philosophy had surpassed German methodology through fundamentally different assumptions about what mattered in modern warfare. His report would begin with a paragraph that captured the essential paradox. The American M101 105mm Howitzer achieves sustained fire rates, double those considered maximum by German doctrine. This performance results not from superior German engineering principles applied more effectively, but from American rejection of German principles entirely. They asked different questions and received revolutionary answers. The implications extended far beyond a single gun design. If American artillery could deliver twice the fire density at half the weight, then German batteries were systematically outmatched in any direct comparison. Numbers that German planners had considered adequate, 4 howitzers per battery, 12 per battalion, were suddenly revealed as insufficient against American units deploying similar numerical strength, but double the effective firepower. Hartmann thought about the broader pattern emerging from captured American equipment: the GMC truck with its perfect interchangeability, the bazooka with its devastating simplicity. Now this howitzer with its optimized firing procedures. Each piece revealed American industrial philosophy that prioritized different variables than German engineering considered important: mass production over craftsmanship, adequate performance over theoretical perfection, battlefield availability over technical sophistication. The Americans were not building better artillery. They were building more effective artillery systems by accepting limitations that German doctrine refused to consider: lower accuracy per round but higher volume, lighter weight but adequate range, simpler mechanisms but reliable performance. Every trade-off optimized for modern warfare's mathematical realities rather than traditional artillery's technical ideals. He wrote late into the night, documenting specifications, recording test data, analyzing tactical implications. The captured howitzer represented more than American engineering competence. It represented American understanding of industrial warfare that Germany was only beginning to comprehend. The nation that could mass-produce howitzers delivering 8 rounds per minute would systematically overwhelm opponents building heavier, more complex guns, delivering 4 rounds per minute. Through his window, Hartmann could see the Mediterranean stretching towards Sicily and beyond it, Italy. American forces were massing for invasions that German intelligence predicted would come within months. Those forces would bring thousands of these howitzers, crewed by soldiers trained in rapid-fire procedures that German artillery schools had never considered possible. The mathematical advantage would be devastating. Tomorrow he would forward his report through proper channels to Berlin. The artillery directorate would read his findings and probably suspect either exaggeration or American propaganda. They would order verification testing. Additional crews would replicate his results. Eventually, months from now, German command would accept that American artillery doctrine had surpassed German methodology through systematic optimization of variables. German engineering had considered irrelevant. But by then, American howitzers would be firing 8 rounds per minute across battlefields in Sicily, Italy, and eventually France. German artillery would respond with 4 rounds per minute from heavier guns, requiring more resources to produce and deploy. The mathematics would decide the outcome long before German industry could adapt production to American philosophy. Hartmann closed his report with a final assessment that would prove prophetic. The American M101 represents American industrial strategy compressed into 3,500 pounds of steel and aluminum. They have built an adequate howitzer and manufactured it in overwhelming quantities. We have built superior howitzers and manufactured them in insufficient numbers. In modern warfare, their approach wins through mathematics that superior engineering cannot overcome. He sealed the report and prepared it for morning dispatch. Outside, the North African night was quiet, except for distant sounds of surf against the shoreline. Somewhere across that sea, American factories were building more howitzers, training more crews, preparing more invasions. The captured gun, sitting on the Tunis firing range, was not an anomaly. It was a preview of the industrial avalanche that would bury German resistance through sheer accumulated volume. The mathematics were absolute. 8 rounds per minute, multiplied by thousands of howitzers, produced fire density that 4 rounds per minute could never match, regardless of individual gun quality. German artillery doctrine had been built on false assumptions about what mattered most in modern warfare. The Americans had asked better questions and received better answers, and Germany was about to pay the price for asking the wrong questions for 20 years. The response from Berlin arrived 6 weeks later, marked with routing stamps that indicated Hartmann's report had circulated through every level of artillery command before generating official acknowledgement. General Major Ernst Brandenberger, Chief of Artillery Operations for OKW, had personally annotated the cover memorandum with a single word written in blue pencil: verify. Hartmann had expected skepticism. Claims that contradicted established doctrine always faced institutional resistance, particularly when those claims suggested German methodology was fundamentally flawed. But Brandenberger's response went beyond skepticism into something approaching desperation. The annotations requested not just verification of fire rates, but comprehensive analysis of how American doctrine achieved these results and whether German artillery could adapt similar methods. By May of 1943, 3 additional M101 howitzers had been captured during operations in Tunisia, providing sufficient examples for systematic evaluation across multiple test sites. Hartmann coordinated with artillery schools at Jüterbog and Grafenwöhr, distributing captured pieces to facilities with experienced evaluation personnel and established testing protocols. The goal was to eliminate any possibility that his original findings represented anomalous equipment or exceptional crew performance. The results from Jüterbog arrived first. Their crew, using American rapid-fire procedures, achieved 7.9 rounds per minute, sustained over 35 minutes. The Grafenwöhr facility reported 8.2 rounds per minute, maintained for 22 minutes, before ammunition supply limitations forced a pause. A third test at the Kummersdorf Proving Ground documented 8.4 rounds per minute as peak performance, with 7.7 rounds per minute sustained for 40 minutes. The data was unambiguous. American fire rate claims were not propaganda or measurement error. The M101 howitzer, operated according to American doctrine, could reliably deliver twice the volume of fire compared to German artillery using traditional procedures. The verification testing had eliminated doubt, but it had also eliminated any remaining hope that German artillery maintained technical parity with American capabilities. Weber compiled the comparative analysis that would form the foundation of German artillery's response to American fire superiority. His background in industrial engineering provided perspective that pure military assessment might have missed. The question was not whether American howitzers performed as claimed, that was now established fact, but why American design philosophy had produced superior results and whether German industry could replicate those advantages. The weight difference is the key to everything, Weber explained, spreading technical drawings across Hartmann's desk. The M101 achieves 4,460 pounds through systematic elimination of every component that doesn't directly contribute to firing capability. Our Lefh-18 carries an additional 3,256 pounds of structural reinforcement, precision mechanisms, and protective features that improve theoretical performance but reduce practical effectiveness. Hartmann studied the drawings. German artillery design philosophy emphasized maximum capability across all conditions. The Lefh-18 could fire at extreme elevations, traverse rapidly to engage moving targets, and maintain accuracy through extended firing sequences. These capabilities required heavy construction, complex mechanisms, and precise manufacturing that added weight and cost while reducing mobility and fire rate. American designers had apparently asked different questions. Instead of building artillery capable of maximum performance across all scenarios, they had optimized for the most common tactical situations: medium-range fire support against area targets, rapid displacement to avoid counter-battery fire, sustained bombardment to suppress enemy positions. The M101 sacrificed capabilities that rarely mattered in actual combat to optimize variables that determined battlefield effectiveness. They're not building the best possible howitzer, Weber continued. They're building the most effective howitzer for modern warfare conditions. There's a difference, and that difference is measured in fire rates and strategic mobility. The tactical implications troubled Hartmann more than the technical specifications. German artillery doctrine emphasized precision fire against identified targets. Battery commanders calculated exact ranges, adjusted for wind and temperature, then delivered carefully aimed fire designed to achieve kills with minimum ammunition expenditure. This methodology worked beautifully in training exercises and against static defenses, where targets remained in position long enough for precise engagement. American doctrine, as revealed through captured field manuals and interrogation of prisoners, emphasized overwhelming fire density over precision accuracy. American battery commanders identified target areas rather than specific points, then saturated those areas with sufficient volume that precision became unnecessary. Individual rounds might miss by 50 meters or more, but 50 rounds fired in the time German batteries fired 25 would still deliver more destructive effect on target. The mathematics favored American methodology in almost every tactical scenario. German batteries achieving 4 rounds per minute needed twice as many guns to match the fire density of American batteries achieving 8 rounds per minute. But Germany was producing approximately 1 artillery piece for every 3 pieces American factories manufactured. The combined effect created a firepower disadvantage that German tactical excellence could not overcome. Intelligence reports from Sicily, where Allied forces had invaded in July of 1943, provided battlefield validation of these theoretical calculations. German artillery units reported being systematically suppressed by American fire that seemed to arrive from everywhere simultaneously. American batteries would fire brief, intense bombardments, then displace before German counter-battery fire could respond. The rapid fire capability allowed American artillery to deliver decisive fire density in minutes, then relocate before retaliation was possible. One report from a Panzer Grenadier Battalion commander described the tactical reality with brutal clarity. American artillery fires 3 times the volume of our own batteries in any given engagement. We can identify their positions, request counter-battery fire, and wait for our artillery to respond. By the time our shells arrive, the American batteries have displaced. Meanwhile, their fire continues from new positions. We are being systematically suppressed by an enemy who shoots faster and moves faster than our counter-battery procedures can address. The rapid displacement capability traced directly to the weight advantage Weber had identified. The M101 could be limbered and ready for movement in less than 2 minutes. The Le FH-18 required 5 to 6 minutes for proper limbering procedures. American batteries could fire, displace, and prepare to fire again from new positions in the time German batteries needed just to begin movement. Combined with their superior fire rate, American artillery was achieving a tempo of operations that German doctrine had never anticipated. Hartmann received orders in September to establish a dedicated training program at the Jüterbog Artillery School, teaching German crews American rapid-fire procedures. The directive acknowledged implicitly that German doctrine had been wrong and American methodology was superior. But institutional resistance remained strong among artillery officers who had spent careers perfecting traditional German techniques. The first training cycle began in October with 40 carefully selected gun crews from frontline artillery battalions. Hartmann opened the instruction with brutal honesty about why they were learning American procedures. For 20 years, German artillery has emphasized precision, fire, and conservation of ammunition. We believed careful aim and calculated fire superiority were the keys to artillery effectiveness. The Americans asked different questions. They asked how to deliver maximum fire density in minimum time. They received better answers. He showed them the comparison data. 4 rounds per minute versus 8 rounds per minute. 7,716 pounds versus 4,460 pounds. 5-minute displacement time versus 2-minute displacement time. Every metric favored American methodology. The numbers eliminated argument. Training German crews in American procedures revealed how deeply traditional doctrine had been ingrained. Experienced gun commanders struggled with the concept of firing without individual aim adjustments between rounds. Loaders accustomed to deliberate, careful ammunition handling found the frenetic pace of American rapid fire almost offensive to their professional standards. The entire system violated German preferences for methodical, precise operations. But after 3 days of intensive drill, the same crews were achieving 7 rounds per minute with German Le FH-18s, nearly double their previous performance. The improvement came not from superior equipment but from superior procedures. American doctrine had optimized the loading, sequence, eliminated wasted motion, and accepted reduced per-round accuracy in exchange for overwhelming volume. German crews could replicate these advantages once they abandoned assumptions about how artillery should be operated. The training program expanded through late 1943 and into 1944, eventually processing over 300 gun crews through American rapid-fire instruction. But the fundamental problem remained unsolved. German artillery could improve fire rates through better procedures, but they could not match American displacement speed while using equipment weighing nearly twice as much as American howitzers. The weight disadvantage was structural, requiring completely new gun designs that German industry was not positioned to produce. Weber's analysis of German artillery production capacity provided sobering context for any discussion of design changes. Germany was manufacturing approximately 1,200 field artillery pieces monthly, across all calibers and types. American production exceeded 5,000 monthly. Even if German engineers designed a lighter, faster-firing howitzer equal to the M101, industrial capacity limitations meant that existing heavy guns would remain in service for years. The Americans could afford to design for optimal effectiveness because their production volume allowed them to field entirely new equipment designs within months. German industry had to optimize existing designs because retooling for new production would create gaps in artillery availability that frontline units could not absorb. Industrial capacity determined which nation could adapt and which nation was locked into existing doctrine by manufacturing constraints. Through the winter of 1943 and into the spring of 1944, Hartmann watched intelligence reports document the systematic expansion of American artillery capabilities. The Italian campaign showcased American fire support, doctrine at scale, with hundreds of M101 howitzers delivering overwhelming bombardments that German artillery could not match in density or duration. One engagement at Monte Cassino provided particularly clear demonstration of American advantages. German defensive positions occupying ancient monastery buildings had proven resistant to infantry assault. American artillery response involved 14 battalions of 105mm Howitzers, delivering a preliminary bombardment that consumed over 190,000 rounds in 6 hours. The volume of fire was incomprehensible by German standards. 14 German battalions firing at maximum sustainable rates would have delivered perhaps 80,000 rounds in the same period. The Americans were not more accurate. Their fire was not more precisely calculated, but they delivered more than twice as many shells on target through superior fire rates enabled by lighter equipment and optimized procedures. The monastery was reduced to rubble not through precision but through overwhelming volume. When German counter-battery fire attempted to suppress American positions, the American batteries simply displaced and resumed firing from new locations minutes later. Hartmann compiled a final comprehensive assessment in May of 1944, synthesizing 18 months of testing, training, and battlefield analysis. The report would serve as the definitive German evaluation of American artillery doctrine and its implications for future operations. He wrote, knowing that the conclusions would provide no comfort to artillery commanders already struggling with numerical and material disadvantages across multiple fronts. His opening summary captured the essential reality. American artillery has achieved systematic superiority through industrial design philosophy that optimizes for battlefield effectiveness rather than theoretical capability. Their M101 howitzer sacrifices precision, maximum range, and complex fire control to achieve double the fire rate and half the weight of German equivalent systems. In modern combat, their choices prove correct, while ours prove inadequate. The tactical implications section detailed the mathematics that German artillery could not overcome. American batteries with 6 howitzers delivered equivalent fire density to German batteries with 12 guns. This meant American divisional artillery, typically consisting of 4 battalions, with 72 howitzers total, matched the firepower of German divisions deploying 144 guns, but American divisions were also more mobile, more sustainable logistically, and better supplied with ammunition. The strategic implications were even more troubling. American artillery production exceeded German production by ratios of 4-1. American ammunition production exceeded German output by factors of 6-1. Even if German artillery achieved parity in fire rates and mobility, which current equipment did not allow, the sheer numerical advantage would remain overwhelming. Weber contributed a section on industrial philosophy that Hartmann considered the most important analysis in the entire report. The Americans treat artillery as industrial products rather than precision instruments. They design for mass production, accepting simplified mechanisms and reduced theoretical performance to enable rapid manufacturing by semi-skilled workers. We design for maximum capability, demanding precision manufacturing and complex mechanisms that require skilled labor and extended production time. Our approach produces superior individual weapons. Their approach produces superior weapon systems through overwhelming numerical advantage. The comparison extended beyond artillery to encompass entire industrial strategies. German factories produced masterpieces in limited quantities. American factories produced adequate equipment in overwhelming volume. Modern warfare favored American methodology because industrial capacity ultimately determined strategic outcomes more than individual weapon quality. Hartmann included recommendations that he knew would be impossible to implement, but felt obligated to document. German artillery should adopt American rapid-fire procedures immediately across all units. This was feasible and would partially offset fire density disadvantages. German industry should prioritize lighter artillery designs, optimized for rapid displacement. This was theoretically possible, but would require retooling that Germany's current industrial capacity could not support. German ammunition production should be expanded to support sustained high-volume fire. This was impossible given competing demands for industrial resources and raw materials. Every recommendation acknowledged implicitly that Germany had lost the artillery competition before the war started. The Americans had spent the 1930s developing industrial mass production capabilities that Germany could not replicate during wartime. The M101 represented decades of peacetime investment in manufacturing infrastructure, design philosophy, and production techniques that enabled rapid deployment of optimized equipment in overwhelming quantities. The report concluded with a paragraph that Hartmann knew would resonate with any honest military analyst reading it. We built the best artillery we could design. The Americans built the most effective artillery for modern warfare. The difference is measured in fire rates, displacement times, and production volumes. We optimized for individual weapon quality. They optimized for system effectiveness. Their questions were better than ours, and their answers are defeating us. By June of 1944, American and British forces had landed in Normandy, bringing with them the largest concentration of artillery the world had ever seen. Intelligence estimates indicated over 2,000 M101 Howitzers were operating in France within 2 weeks of the invasion. German artillery opposing these forces numbered approximately 800 pieces across all calibers. The numerical disadvantage was 3-1. The fire density disadvantage, accounting for American superior fire rates, exceeded 6-1. Hartmann received reports from Normandy that confirmed what testing and analysis had predicted. German defensive positions were being systematically obliterated by American artillery fire that arrived in volumes German troops had never experienced. One artillery observer reported that American bombardments sounded like continuous thunder rather than individual explosions. The rate of fire was so high that individual rounds could not be distinguished. The effect was psychologically devastating before it became physically destructive. German counter-battery fire proved largely ineffective against American artillery. By the time German observers identified American battery positions and requested fire missions, the American batteries had displaced. German shells fell on empty positions while American howitzers continued firing from new locations. The weight advantage that allowed 2-minute displacement times was proving decisive in the counter-battery battle. Ammunition expenditure rates demonstrated the industrial disparities underlying American artillery superiority. A single American artillery battalion in Normandy fired an average of 3,000 rounds daily during active operations. 14 battalions in a division consumed 42,000 rounds per day. American logistics delivered this ammunition without apparent strain. German artillery battalions were rationed to 600 rounds daily, and even these reduced allocations frequently failed to arrive due to Allied air interdiction and transportation limitations. The Americans were fighting an artillery war of unlimited abundance while Germany fought with carefully rationed scarcity. The mathematical outcome was predetermined. Abundant firepower would systematically destroy limited firepower through sustained volume that rationed forces could not match. Hartmann had seen this pattern in the test data 18 months earlier. Now it was manifesting across the battlefields of France with devastating effectiveness. In August of 1944, Hartmann was reassigned to organize artillery training for newly formed Volksgrenadier divisions being created to replace losses in France. The assignment carried bitter irony. He would be teaching artillery doctrine to replacement troops, knowing that German methodology was systemically inferior to American practice. He would be training crews to operate heavy, slow-firing guns, while American artillery delivered twice the fire rate from lighter, more mobile platforms. But German industry could not manufacture lighter artillery in quantities needed to replace existing guns. The FH-18 would remain standard equipment because no alternative existed in sufficient numbers. Training would emphasize American rapid-fire procedures adapted to German equipment, achieving perhaps 5 rounds per minute instead of 4. The improvement was meaningful but insufficient. German artillery would remain systemically outmatched against American firepower. The Volksgrenadier program revealed how thoroughly Germany's artillery capabilities had degraded by late 1944. Experienced gun crews had been casualties of earlier campaigns. Replacement troops received abbreviated training measured in weeks rather than months. Equipment consisted of worn guns that had seen hard service and captured foreign pieces that complicated logistics and training. Ammunition remained rationed at levels that prevented effective fire support for offensive operations. Hartmann drilled his new crews in rapid-fire procedures that would help them survive rather than win. Fire quickly, displace immediately, avoid, counter-battery suppression. The tactics were defensive, designed to maximize survival rather than achieve fire superiority. German artillery had been reduced to harassment rather than decisive fire support. American artillery, meanwhile, delivered bombardments measured in hundreds of thousands of rounds per engagement. By December, Hartmann found himself in the Ardennes, attached to an artillery regiment supporting the offensive that German High Command hoped would change the war's trajectory. The plan required German artillery to suppress American defenses during the initial breakthrough, then provide fire support as panzer divisions advanced toward the Meuse River. Success depended on artillery performance that Hartmann knew German equipment and doctrine could not sustain. The offensive began December 16th with German artillery bombardments that consumed carefully hoarded ammunition reserves. For 30 minutes, German guns fired at maximum rates, attempting to replicate the overwhelming fire density that American artillery achieved routinely. The volume impressed German infantry, who had rarely seen such intensive fire support. But the bombardment exhausted ammunition supplies that could not be rapidly replaced. American artillery response demonstrated the systematic advantages that testing had revealed 18 months earlier. Within hours of the German attack, American batteries were delivering counterfire that exceeded German offensive bombardments in density and duration. American logistics delivered ammunition that sustained high fire rates through days of continuous operations. American mobility allowed rapid concentration of artillery to threatened sectors. German artillery had fired its prepared ammunition in the opening hours. American artillery was just beginning to demonstrate its true capabilities. The mathematical imbalance became apparent within 48 hours. German guns fell silent as ammunition supplies were exhausted. American Howitzers continued firing, delivering thousands of rounds that systematically destroyed German assembly areas, supply routes, and command posts. Hartmann watched American artillery doctrine operating at division and corps scale, exactly as testing had predicted it would perform. Rapid fire rates delivered overwhelming volume, lightweight enabled quick displacement to avoid counter-battery fire. Industrial abundance ensured unlimited ammunition supply. The M101 Howitzer was not individually superior to German artillery, but the system was crushingly effective through accumulated advantages that German equipment and doctrine could not counter. By Christmas, the Ardennes offensive had stalled under American artillery fire that German troops described as beyond anything previously experienced. The failure was not tactical or operational. It was mathematical. American artillery simply delivered more shells on target than German forces could withstand, while German artillery lacked the capacity to suppress American fire support. The industrial competition had been decided by production volumes and design philosophies established years before the first shots were fired. In January of 1945, as German forces retreated from the Ardennes, Hartmann received orders to evacuate artillery equipment toward the Rhine. Much of it would be abandoned for lack of fuel to tow the guns or destroyed to prevent capture. He supervised the demolition of Le FH-18 howitzers that had served faithfully but could not match American capabilities. Each gun destroyed represented thousands of hours of skilled labor, precision manufacturing, and German engineering excellence. But excellence had proven insufficient against American volume. The captured M101 that had started his analytical journey in March of 1943 had been lost somewhere in Tunisia, probably destroyed during the final Axis collapse in North Africa, but thousands more were. Operating across Europe, delivering 8 rounds per minute in the hands of American crews who had learned to operate them in weeks rather than years. German artillery firing 4 rounds per minute from guns weighing twice as much could not compete with that systematic advantage. Years later, in 1952, Hartmann would participate in interviews conducted by American military historians studying German perspectives on Allied equipment. He would explain how testing a captured howitzer had revealed fundamental flaws in German artillery doctrine. The Americans would ask whether German engineering could have produced equivalent weapons given sufficient resources and time. Hartmann would answer honestly. German engineers could have designed lighter, faster-firing artillery, but German industrial philosophy prioritized precision over mass production, quality over quantity, theoretical perfection over practical effectiveness. The M101 represented American rejection of these priorities in favor of systematic optimization for modern warfare requirements. Different questions, different answers, different outcomes. The Americans had asked how to deliver maximum firepower with minimum weight and received revolutionary answers. German artillery had asked how to achieve maximum precision with optimal ballistic performance and received traditional answers. In industrial warfare, revolutionary answers defeated traditional approaches through accumulated mathematical advantages that tactical excellence could not overcome. The humble M101 howitzer, crude by German engineering standards, had won the artillery war through superior fire rates enabled by intelligent design choices and supported by industrial capacity that treated weapons as mass-produced products rather than precision instruments. 8 rounds per minute had defeated 4 rounds per minute through simple arithmetic. 4,460 pounds had defeated 7,716 pounds through superior mobility. American questions had proven better than German answers. The captured howitzer had revealed more than American artillery capabilities. It had exposed fundamental weakness in German military-industrial philosophy that treated weapons as individual masterpieces rather than system components. Modern warfare demanded the system, not the masterpiece. The Americans understood this. The Germans learned it too late to matter. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.